Alrighty, now we're going to talk about effect size. Effect size is how you determine the difference between if something is statistically significant versus if it's practically significant or clinically significant. Let me give you an example of what I mean by this. Let's return to the example that I've used a few times this semester about, let's say, hypothetically, Penelope. Let's say hypothetically I had developed an app for meditation and I was using it to see if it helped anxiety-related insomnia among students, right? Let's say I gave everyone who tested this app, had them log their sleep, and I came back showing that I had statistically significant results, okay? Let's say I got a P of, I don't know, let's say I got a P of 0.036, meaning there was only a 3.6% chance that this happened by chance, by coincidence. So I have statistical significance, and by a good margin, right? I wasn't right on the line of P05. Like I got myself down to the P 0.036. I'm good, right? I'm well below my 5. But let's say when I actually get more into my data, I show, okay, it worked and it helped my students with insomnia get more sleep. It helped them get, on average, an extra 4.6 minutes of sleep every night. Okay? So I tell you, okay, use this app and meditate for 30 minutes before bed because it's statistically significant. Is it really going to matter that much if it's an extra 4 minutes of sleep? Is that practically significant to your life? This happens quite a bit if you see advertisements for weight loss drugs or things like that. There used to be commercials for these things all the time. Clinically proven that if you add in this pill, this supplement shake, this whatever, that they lose more weight than the control group that was just doing diet and exercise, right? And there were lots of these that if you logged on and actually looked at the little asterisk that they put on the commercial, which they have to do, because if they're going to say that, they have to provide you with where they got it, you would see that, okay, well, over a 3-month trial, the participants who took their drug maybe lost an extra 1.2 pounds. Is it worth taking a drug that's $100 a bottle that's probably going to give you a headache and all sorts of stomach issues to lose an extra pound in 3 months? They might have found statistical significance. That's not really practically significant for their consumer. So this is why you always want to double check, especially with products. If someone is trying to sell you something and it says, no, but research shows this works, look at the numbers, because sometimes they might have achieved statistical significance, but it's not really a practical difference. If we're evaluating drugs, if we're evaluating clinical therapies, we often call this clinical significance. You got statistical significance, but was it clinically significant? Is it actually going to matter for your patients? Now, the way we calculate this is using something called Cohen's d. And Cohen's d is a measure of effect size. So your effect size is exactly what it sounds like. It's a self-explanatory term. What is the size of your effect? My app affects sleep. Okay, what is the size of that effect? How much does it affect it? And the way you calculate this is you subtract the mean of one of your groups from the mean of your other group. So your experimental group, your control group, your subset, your population. You subtract the mean of one from the mean of the other, and you divide it by the standard deviation. That's it. That's your effect size. And that lets you compare things on different scales. This lets me compare a test that might have been on a 10-point scale with a test that was on a 30-point scale. Let's say you use 2 different measures of anxiety, right? And I would say if there's anxiety reduction. That lets me compare apples to oranges of these 2 different scales that were scored differently, because what I can still look at is the effect size, because I'm going to get a comparable difference since we're using means and standard deviations. So that in a nutshell is clinical significance, practical significance versus statistical significance, and using effect size to calculate it. So go through a couple of the examples in your book, make sure you understand it, email me with any questions about that.